One of the world's most modern automotive plants is located in Sindelfingen. Mercedes-Benz builds its luxury class vehicles in this fully networked super factory. Here, 2,000 employees and an armada of robots produce the world's most popular luxury sedans. Like the factory in which it's built, Daimler's flagship, the S-Class, is packed full of high tech. In its 7th generation since 1972, the 100,000 euro car shares an assembly line with its electric sibling, the EQS, and the world-famous Maybach. Building conventional hybrid and electric luxury class cars on a single production line is unique in the automotive sector. Located in the main Mercedes plant in Sindelfingen, Factory 56 covers 220,000 square meters. The mega project took 2.5 years to build and cost 730 million euros. With its innovations, the high-tech factory is akin to a journey into the future of automotive manufacturing. The aim here is to produce the S-Class, Maybach & Co. in the most sustainable and eco-friendly way possible. Inside, the group is now building its luxury sedans 25% more efficiently than in the old hall next door. In the naturally lit mega factory, people and machines are part of a digitally networked whole. "2,000 workers, dozens of robots, and hundreds of autonomous transporters operate like clockwork to produce the new S-Class generation, the EQS electric sedan, and the luxurious Maybach. The classic assembly line has made way for highly efficient series production.
We can produce conventionally powered, hybrid, and also fully electric vehicles on a single line here. This is an innovation and a global first. But not only that, we can also produce sedans or SUVs, compact cars, the Maybach, or even fully electric vehicles here in this building.
One of the 400 automatically guided vehicles, or AGVs, is heading to the first S-Class production station. The special feature of these fully electric production aids is their flexibility. Depending on use, they can be fitted with various special bodies, allowing them to perform diverse tasks. Once a minute, the computer-controlled logistics system in the suspended ceiling loads the AGVs with freshly painted body shells. Over the next few days, the cars pass through hundreds of assembly stations until a new Mercedes S-Class is finally produced. The top model in the new Mercedes-Benz S-Class range bears the name S580 4MATIC. An impressive 523 horsepower can accelerate the 2 metric ton sedan from 0 to 100 kilometers per hour in 4.4 seconds. The V8 bi-turbo engine with a displacement of 4 liters is electronically limited to 250 kilometers per hour. Depending on equipment and interior comfort, the luxury sedan costs upwards of 130,000 euros. In Sindelfingen, each car starts its life with these coils, rolls of sheet steel or aluminum weighing several tons. The unrolled material passes through a laser blanking system, where 3 lasers precisely cut out shaped panels that are subsequently used to manufacture the body. The cutting heads operate at up to 100 meters per minute, and therefore produce 12,000 blanks a day. At the end of the day, the machine has consumed 72 coils, an unimaginable number for previous pressing and cutting methods.
The laser blanking system is fully flexible in terms of the components that can be produced on it. Previously, a cutting tool was needed for each component, requiring lots of space and conversion time. Today, everything is programmed in the system and can be switched over very quickly to a different component that's currently needed to meet customer demand.
The system spits out a batch of S-Class sidewalls. 300 blanks, each weighing 15 kilograms, are stacked on the carriage. The aluminum plates don't look anything like a car yet. Brute force and a gigantic machine are needed to transform the flat sheets into a new sedan in the press shop in Sindelfingen. "110 meters long, 25 meters wide, 12 meters high. This servo transfer press is a pure superlative." The workers feed the hungry system in Hall 17 using an overhead crane. Several hundred blanks disappear into the giant's press maw each hour. The rest then takes place fully automatically. Inside, up to 6 individual pressing stages await the metal sheet, depending on the component being produced. Like a gigantic anvil, the flat blanks are mechanically punched, formed, and bent between the two clashing die halves.
We give the vehicle its face here. The blank is flat and we turn it into a molded part.
The dies, as the red press molds are also called, operate with a force of 2,500 metric tons. Molds for engine hoods, trunk lids, roofs, door panels, or side panels are stacked several meters high alongside the system. It takes the team just 1 hour to exchange one of the 60-ton dies in the servo transfer press. Then the process can continue with full force.
For the sidewall, we run at 15 strokes per minute, or 900 per hour. I can run some components even faster. That depends on the structure, the geometry, and the material, whether it's steel or aluminum. So the system can do more, but it usually runs at around 15 strokes or 900 parts per hour.
Each part coming from the press shop is checked by trained quality inspectors. Body panels with hairline cracks or deviations are detected and rejected here early on. The body of the S-Class has always made a statement. Mercedes has been building its special class since the early 1970s and has made the car one of the world's most successful luxury class vehicles ever, with over 4 million models sold. From the press shop, the formed body panels proceed to the body shop. Covering an area of 100,000 square meters, the body shop is one of the largest departments in Sindelfingen. This is where more than 1,000 robots weld, rivet, and bond the vehicle's body fully automatically in the tightest of spaces. Thanks to complex software, each of them knows whether it has to produce an S-Class, a Maybach, or an EQS, and adapts its operation steps accordingly. Here, humans are solely responsible for checking and maintaining the systems.
We have a material mix consisting of aluminium and steel, and we use 10 different joining technologies to join these parts. They range from conventional steel spot welding to ultra-modern laser welding.
In the body shop, dozens of puzzle pieces are transformed into a highly complex body in just a few hours. In an emergency, this vehicle carcass has to be able to withstand extreme physical forces. For a vehicle with a weight of 2 tons and a maximum speed of 250 kilometers per hour, occupant protection is given top priority, which is why the steel and aluminum body has been constantly evolved in numerous crash tests. The list of technical innovations that Mercedes-Benz has introduced with the S-Class is long. Since the 70s, the German automotive manufacturer has been building experimental safety vehicles, or ESFs, to test new safety systems and develop them to market maturity. For instance, ABS was first fitted as standard in the W116 model series in 1978. During this period, designers and engineers' focus increasingly shifted to safety in addition to the vehicle's handling characteristics. Crash tests were developed and innovative passive safety systems were invented. The first airbags and seatbelt tensioners were fitted in the S-Class in 1981. Prosperity in post-war Europe led to considerably more cars and much denser traffic on the roads, a change that resulted in new safety needs in society. As a consequence, new crash tests, such as the side impact or the asymmetric frontal impacts, were developed. For Mercedes, the S-Class has always been the pioneer in terms of safety engineering. Technical innovations such as adaptive cruise control or infrared night vision were launched in the luxury sedan at that time. Back to the present. The car bodies that are just leaving the body shop are fully assembled. In the light tunnel, 2 employees thoroughly inspect the surfaces for deviations and polish the vehicle's untreated panels. No machine can take the place of the human eye or the feeling in the fingers, even in one of the world's most modern car factories. Each emerging S-Class continues on its way in this gigantic system. This is where the body goes for a dip. The 50-meter-long dip tanks in the paint shop are filled with a special liquid primer. Now the electricity starts to flow as e-coating begins. E-coating is an electromechanical dip painting method in which the vehicle's body is negatively charged and the paint in the tank is positively charged. During the dipping process, the body attracts paint particles due to its opposing charge. This ensures that the phosphate-based rust protection gets into even the tightest of spaces in the metal carcass and protects the vehicle from oxidation and cavitation.
Another big advantage of the e-coating dip tanks is that they have an infinite service life. And the materials that we deposit onto the body shell are constantly resupplied as fresh material. So this is actually a resource-efficient cycle.
The dipping process only takes a few minutes. Each body shell runs through 5 such dip tanks and is then ready for painting. The vehicle is painted on the painting line. The system assigns the vehicles to one of the 2 branches fully automatically. Over the next 60 meters, 30 robots apply 3 further coats of paint onto the electro-deposited primer. An additional primer, the base coat, which lends the vehicle its color, and a layer of clear coat for sealing. The system is highly efficient and sorts the vehicles by color in advance.
In terms of efficiency, the system could theoretically paint each vehicle in a different color, but we don't do that. We actually form color blocks consisting of at least 3 to 5 vehicles. In extreme cases, we sometimes have 20, 30 or more vehicles that we run through in a color block.
The system can produce 28 different colors. When it's fully painted, the body of the S-Class is around 4.5 kilograms heavier.
We can supply all colors of paint using a ring circuit system here. The individual robot only takes the amount of paint from the ring circuit that it needs to paint the vehicle. It then pumps the paint that it doesn't need back into the ring circuit.
Once the exterior has been dealt with, focus now turns to the luxury sedan's internal qualities. In preparation for the next workstation, technicians fit special fill plugs in the interior. Once again, the rest is undertaken by robots. They fill cavities in the body with acoustic foam. When hardened, the material reduces driving noises in the interior. Extensive studies are necessary to deaden noises in the passenger compartment. To do this, a gigantic frame is lowered from the ceiling in the Sindelfingen test center. It contains hundreds of highly sensitive microphones. The passengers on this trip are two artificial heads with microphone ears. The test drive starts at 140 kilometers per hour. The test stand's giant blower now generates the airstream. The unpleasant driving noises are produced by eddies at the edges and convexities of the vehicle's paneling. The engineers call this aeroacoustics. To reduce the noises, they can redesign the shape of the car to be more curved or flowing. The acoustic foam helps to reduce unavoidable wind noises. It absorbs the sound waves and makes things quieter inside the car. However, not all processes in the paint shop are fully automated. Good old manual work is also available if you're willing to dig deeper into your wallet. In the manufactory, painting specialists fulfill every special request and finish the vehicles by hand, even in pink if need be. The manufactory is also home to the Maybach's striking two-tone paint finish. The ultimate luxury upgrade from Sindelfingen can be had for the price of 10 compact cars, the Mybach S-Class. With the starting price of around 200,000 euros, the two-tone road cruiser is even more striking. An impressive 612 horsepower and 900 newton meters accelerate the 2.3-ton sedan from 0 to 100 kilometers per hour in 4.5 seconds. The V12 engine with a displacement of 6 liters is electronically limited at 250 kilometers per hour. Luxurious automobiles bearing the name Maybach were first built back in 1921. After a number of takeovers and pauses, Maybach has been wholly owned by the Mercedes-Benz Group since 2014.
The vehicle is 18 centimeters longer than the long wheelbase S-Class in terms of both its exterior length and its wheelbase.
After 2010, production of the Maybach was actually set to be discontinued due to competition with the S-Class. Today, both vehicles are once again siblings and stand out through their technical innovations such as gesture control and their humor.
Hey, Mercedes.
Yes?
Tell me a joke, please.
Which is a pirate's favorite key on the keyboard? The Enter key.
That's certainly not going to win any comedy awards, but it ought to put a smile on the driver's face. Far from the bustle of large-scale production, a few Maybachs are being given the personal touch in the manufactory. For the two-tone paint finish, the standard base coat is first sanded until it's dull. Then the lines are masked by hand, and the upper part of the vehicle is manually painted in the second color. Finally, clear coat is used to seal the luxury paintwork.
The paintwork takes far more effort. It involves a lot of manual work. It's a manufactory. Nothing here is done by machines or robots, but by highly trained staff who work very intensively on the vehicles and have to meet the highest standards of quality.
The unique presence that affluent Maybach customers around the globe appreciate is created in painstaking manual work in the manufactory. The pace in Factory 56 is completely the opposite of that in the manufactory. The interiors of the fully painted bodies are now set to be installed. To do this, the doors are first removed at Station 1. They hinder the workers and make it difficult for them to access the interior. Both of the doors per vehicle side are strapped onto a transport carriage. All 4 bear the body's digital signature and can be identified at any time during the long journey that lies ahead of them. A conveyor system transports the pairs of doors into the hall's suspended ceiling. The beating heart of Factory 56 is located up here. A rail network with a length of several kilometers resupplies the assembly stations one floor down, or distributes specific assembly groups throughout the 220,000 square meter hall. The doors, for example, now have to proceed to pre-assembly, where they are fully assembled on a separate line. Like in a steel ecosystem, everything in Sindelfingen's high-tech car factory is interlinked. This enables very flexible responses to changes, such as the launch of a new model. Large systems or robot stations are bundled at very few points in the hall. There are therefore only isolated locations in the manufacturing process that are rigid and fixed. The engineers call this tech line. Only this enables the three models, the S-Class, Maybach and EQS, to be built on a single production line. And if new models have to be produced here in the future, only these fixed modules have to be converted.
When we integrate new products, we can simply integrate new systems into TechLine, change the lanes used by the industrial trucks, and thus integrate new model series pretty easily. The rest of the interior equipment can remain as it is. We don't need any more stations.
Various guidance systems for the automatically guided vehicles are located on the hall floor. The colored lines and digital codes act as an extensive transport network throughout the hall and enable all of the assembly stations to be reached. The high variability of the vehicle equipment makes it impossible to store equipment parts directly next to the assembly stations. The AGV's digital ballet therefore helps to provide the correct parts whenever and wherever they're needed. Tracked live and networked, more Industry 4.0 is hardly possible.
These shopping baskets help us to always provide the worker with the diverse parts for the specific vehicle. It's all done with over 400 automatically guided vehicles that transport the shopping baskets from a picking zone directly to the worker at the line.
For example, numerous dashboards can be seen crossing the hall. The instrument panels cover 250 meters on the back of an autonomous AGV. They come from a production line next to the main line. One dashboard follows another in cockpit pre-assembly. Each of them is individually configured according to the customer's wishes. The employees assemble the instrument panels here at various stations. The system specifies what has to be installed. Parts such as this head-up display are delivered fully automatically by shopping basket and can be installed immediately. This unassuming component's capabilities border on science fiction. Mirroring is used to project information onto the windshield in the driver's field of vision, making it appear as if the graphics were on the road and part of reality. The dashboard puzzle consists of dozens of individual parts and assembly groups that are assembled in a specific sequence. Particularly sensitive parts, such as the driver's display, are fitted with special protective covers so that they aren't scratched during installation. The progress made in automotive engineering is clearly visible here. The 12.3-inch TFT screen now sits where the analog speedometer and tachometer used to be. The roughly 100-kilogram dashboard continues on its way to the main assembly line. The magnetic strips in the hall floor guide the AGV and its cargo punctually and precisely to Cockpit Assembly at Station 79. An EQS is already waiting for its instrument panels among S-Class and Maybach vehicles. That's what makes this place so special. Various drive types and models take turns at the assembly stations as a matter of course. The EQS is the first fully electric luxury sedan to be built by Mercedes. Up to 523 horsepower with a maximum speed of 210 kilometers per hour are then available from 97,000 euros. The electric architecture consists of a battery module with nickel-cobalt-manganese cells. Depending on the driving style, the vehicle has a cruising range of up to 785 kilometers. The electric motor is mounted on the rear axle. A second electric motor on the front axle ensures additional power in the four-wheel drive models. Cockpit assembly is identical for all model series in Factory 56. The operator effortlessly releases the pre-assembled dashboard from the AGV using an electric robot arm. To be able to operate the lifter, he first had to undergo special training to obtain a certificate. There isn't a lot of room to get the component into the S-Class without damaging it. It takes the team at Station 79 120 seconds to install it. The cordless drills used by the technicians are part of the digitally networked production system. The force used to tighten each individual screw is programmed by the system. At the front, a worker is fitting the car battery. He too uses these networked tools. The internet-enabled tools incessantly collect data that the Factory 56 software specialists can subsequently use to assess the effectiveness of the production processes, with the aim of optimizing everything in terms of efficiency. A gigantic data set documenting when, where, and how each screw was tightened is therefore produced for each vehicle that is built. This analysis data can be called up years in the future and used, for example, to clarify an accident or help to determine the cause of a technical failure. But the system does not only consume data, it also provides the workers with important information. All of this functions via these sensors. Hundreds of them are scattered throughout the entire hall. They track each vehicle and its progress in real time. To do this, the sensor system requires a stable broadband Wi-Fi network. So that nobody here complains about poor internet coverage, Mercedes has set up the world's first 5G cell phone network in a vehicle production plant. All tools also communicate in this network. The Internet of Things is no longer a vision of the future here. The collected real-time data flows directly into the digital ecosystem. 30 Mercedes-Benz car production plants around the globe are already linked together. Industry 4.0 with big data and intelligent tools. Run-of-the-mill in Factory 56.
The hall has a complete positioning system, so we know exactly which vehicle is located exactly where and what it needs at any given time. This means we can instantly provide our employees with any information they need to produce the vehicle efficiently, but also to high quality. This is a new philosophy, a new step. There has never been a hall that has implemented this overall concept as comprehensively as our Factory 56 before.
The workforce in the axle assembly department is also fully networked. A quality assurance employee is checking a finished powertrain here. His handheld scanner tells him how the 5-meter-long powertrain, consisting of the engine, transmission, and the axle assembly groups, has to be configured so that it can be installed in the body shell. At 15 stations, the technicians assemble all of the 8-cylinder engines for the S-Class and the 12-cylinder engines for the Maybachs, forming powerful drive units. While the propeller shaft is being bolted, the factory network stores and checks all of the data again. Assembly errors can therefore be virtually ruled out. Automotive Engineering 4.0 is also demonstrated a few meters further on. An enormous battery pack is located among the combustion engines. With its electric motors, the powertrain of an EQS is from a different planet in terms of its technology. But it also can be produced here in the pre-assembly department. Whether gasoline or electric, they all walk down the aisle. Directly next door, the Mercedes registry office awaits the next bridal couple. The marriage is what car manufacturers call the point at which the powertrain and body are bolted together. While the S-Class, Maybach, and EQS body shells glide in, the appropriate powertrains are lining up beneath. Mercedes calls this innovative process the full flex marriage.
Ultimately, the full flex marriage process means that we can run several models on one line. That offers us maximum flexibility from conventional combustion engines and plug-ins to fully electric vehicles. We can react accordingly to fluctuating quantities.
The process starts. The body and powertrain are positioned exactly above one another. A hydraulic platform then raises the powertrain. Two workers step onto the platform from each side. They have less than 1 minute to tighten the almost inaccessible threaded connections. No machine would be able to do this work in the cramped wheel well. All connections on the underside are fastened fully automatically by a screwing robot. The marriage is then finalized at the push of a button. In automotive engineering, man and machine have always worked hand in hand. Particularly so in Sindelfingen. In this regard, Mercedes can look back at a long history. Cars have been built at the group's main plant since 1919. Making Sindelfingen near Stuttgart one of the oldest automotive production sites in the world. Since the 50s, this location has been regularly expanded and new production halls have been built. The W123 model series that was produced in Sindelfingen remains the top-selling Mercedes model. This is also where production of the W116 model series, the first S-Class, began back in 1972. The global success of the S-Class has particularly been driven by innovations in the area of passenger safety. The special class from Sindelfingen has always been one of the safest cars in the world, something that has been appreciated above all by presidents, CEOs, and VIPs, but also by dictators. The who's who on the back seat ranges from Nelson Mandela and Angela Merkel to Saddam Hussein. The car manufacturer's innovativeness has been the driving force behind its success over the decades. Factory 56 is continuing this tradition in a new way. Mercedes-Benz aims to be completely CO2 neutral by 2039. The photovoltaic system on the roof shows how serious the Swabians are taking this goal. The 12,000 solar modules are able to generate 30% of the factory's annual energy needs. Surplus solar energy is stored in an accumulator made of recycled car batteries. Capacity, 1,400 kilowatt hours. Now it's time for the S-Class to get its face. The headlamps, front apron, and grille are set to be installed. What's being installed here with just one screw is a technical revolution. The digital light system is far more than a pair of lamps that light up the road. The two headlamps are able to project information in the form of graphics onto the road. The modern digital light system is a real automotive revolution. Each headlamp is technically comparable to a video beamer with a total resolution of over 2 million pixels. Each pixel can illuminate or mask an area measuring 4 by 2.5 centimeters at a distance of 100 meters. At present, comparable systems can only do this with around 2 by 2 meters. Each lamp is fitted with 3 powerful LEDs that illuminate a thumbnail-sized chip with 1.3 million tiny mirrors. They reflect the light onto the road through a projector. If one mirror is turned by 10 degrees, one of 2 million pixels is deactivated, enabling other road users to be simply blanked out. As in the case of this show car, the headlamps could also project road signs and symbols onto the road surface. To do this, the system uses data from sensors, cameras, and navigation satellites. This technology has not yet been approved in Germany, meaning that the standard S-Class will initially have to forego this innovation. Such projections could warn the driver ahead of construction work, for example, or guide them through narrow lanes. The Show S-Class can also increase passive pedestrian safety with its intelligent light system. For instance, a projected crosswalk indicates to pedestrians that the vehicle is braking and it is safe to cross the road. Once the headlamps are fitted, all that's missing to complete the S-Class's face are the front apron and the radiator grille. A large sensor unit is located centrally behind the air inlet grille. It checks the distance from other road users and triggers emergency stop for the 2 metric ton sedan when necessary. Extensive tests were necessary to develop and fine-tune the assistance and safety systems. Since 2018, Mercedes has been operating its own development center in Immendingen, 130 kilometers south of Stuttgart. Covering a total of 520 hectares, this site boasts 68 kilometers of tracks, from asphalt to gravel. The 30 simulation areas for diverse traffic scenarios cause every test engineer's pulse to race. Covering 100,000 square meters, the Bertha area is one of the biggest asphalted areas in Immendingen. Space that Mercedes-Benz developer teams need for extreme maneuvers. The 950-meter-long and 650-meter-wide asphalt slab offers sufficient room to expose the assistance systems to life-threatening traffic situations and push them to their limits at high speeds. The developers put the systems through their paces over thousands of kilometers and filled their hard drives with life-saving data. In terms of its sensors and software, the 7th generation S-Class is equipped so that not much more is needed before it can drive autonomously. However, reverse parking already poses hardly any problems for the computer at the wheel. The future of autonomous mobility really isn't that far away. Developers and engineers are already busy collecting data. Their challenge is to prepare the sensors and the connected systems for an infinite number of possible traffic situations. Road markings, signs, and traffic light systems often differ significantly from country to country. The developer team has to create a car that can drive on any continent, which is why the engineers are taking their wards around the world. What functioned in theory at the test site in Immendingen also has to stand up to harsh reality. The roads in China are the absolute Champions League in terms of confusing traffic. The lane markings and signs with Chinese characters are not a major challenge for the vehicle's software and sensors. The developers are more interested in the traffic flow and the behavior of road users instead. Only a car that can understand other cultures will be at home on any continent, come rain or shine, during the day and at night.
We found a lot of great traffic scenarios that we could measure, where we could gather info from the radar and the camera and our sensors that we logged on the computers, and that's something we really want to look into in a lot more detail when we're back home at our servers, and compare it to the situations that we know from back home and from the United States, obviously.
This prototype shows how autonomous vehicles might look in the future. Mercedes-Benz presented its F-015 research vehicle back in 2015. The futuristic 5-meter-long S-Class reached a top speed of 200 kilometers per hour with 272 horsepower generated by 2 electric motors, and was already able to do without a driver. However, the realization that the role of cars will change dramatically is far more important than the technology itself. All stakeholders agree on that.
Thanks to autonomous driving, we humans will regain time and space that we can use in a completely different way to communicate with one another, or whenever you're tired, to simply relax and enjoy this wonderful ambience driving down the strip at midnight. That's only possible in a futuristic car like this.
Several years have passed since the Mercedes F-015 was presented, but nothing has changed about the vision of autonomous driving or people's fascination with it. It remains to be seen whether cars will really become driverless habitats in the future. Besides big data and CO2 neutrality, Factory 56 in Sindelfingen is focused above all on its employees. Ergonomics and preventive healthcare are therefore fixed elements of automotive production. Nobody has to hold the heavy screwdrivers or lift the wheels any longer when they're being fitted. An AGV transports them independently to the assembly line. The workers use the positioning carriage to place the wheel on the 5 retaining bolts in the wheel well. The automatic system then takes care of the rest. While it tightens the nuts to the defined torque, the screwing station travels along parallel with the line. Once everything is tight, the automatic machine disengages from the vehicle and is immediately ready for use on the next car.
In Factory 56, we focused on the issue of ergonomics in a very early project phase. We didn't concentrate solely on the processes. Instead, we particularly asked ourselves how we can enable the person who's going to be carrying out this process later on in the hall to perform their work well. With the C-shaped suspension devices, for example, where mainly underbody components are fitted, I can also rotate the vehicle around an axis. This means that I can rotate the underbody towards the employee so that they can fit the underbody components in a natural body posture, which would otherwise have to be done overhead.
The seats are also ergonomically moved into the passenger compartment using a mini crane. The S-Class is now on the home stretch. The luxury interior of the €100,000 sedan is almost completely installed. In the vehicle, the occupants are seated in a mobile spa-like oasis. The leather-upholstered seats with massage function heat the passenger's neck, arms, back, bottom, and even their hands. 4 screens, 2 in the front and 2 in the rear, make sure that nobody gets bored. The S-Class is now on its own wheels for the first time, but the road cruiser is still lifeless. That's going to change now. At this gas station, there is no coffee or newspapers, but instead, everything a car needs to drive. An employee attaches various nozzles to each of the fluid reservoirs in turn. The brakes, radiator, air conditioning system, and windshield wipers are now filled automatically. But there's no gasoline yet. That's too dangerous. The car still has a few final stations to go, and the workers shouldn't be exposed to any unnecessary hazards. They only fill the car with 20 liters of fuel shortly before the end of the production line, so it can leave Factory 56 under its own steam. Now it's time for a happy reunion. The doors that were removed at Station 1 are lowered from the suspended ceiling. Like the car itself, they've been fully fitted with components and electronics. This driver's door was completely assembled elsewhere in the plant a few hours ago. Pre-assembly takes place on this 60-meter-long assembly line, at the start of which the bare doors arrive from the suspended ceiling after being removed at Station 1. First, the employees bond in the sound insulation. The factory network tracks each door and organizes resupplies for the downstream stations. Over 70 components, including the window lifters, speakers, or the armrest heating, are installed in the interior. Lots of electronics. The employee now connects a control unit. Far from the car itself, they can check whether the door functions, whether the window lifter can be operated, and whether the ambience LEDs light up. If everything's okay, the doors are ready to be installed. No matter whether they're for a Maybach, an EQS, or an S-Class, all doors are treated as equals in Sindelfingen and are installed at Station 334 using an assembly lifter. All of the work on the luxury interior has now been completed, so the doors will no longer pose an obstacle to the technicians. The S-Class enters the last leg of the production line via a turntable. A final crucial detail will be fitted here. The three-pointed Mercedes star symbolizes the fact that Daimler engines are used to power vehicles on land, in the air, and on water. So each point represents one of the 3 elements. The journey undertaken by the S-Class through Factory 56 is now coming to an end under the fluorescent lights in the quality control department. The result of many hours of work, performed by hundreds of people, now has to withstand the keen gaze of the inspectors. The handheld scanner is used one last time before the employee removes the tracking code. A final visual inspection is performed in the interior. And then, the moment has arrived. The engine is started for the first time. Once the S-Classes leave Factory 56, they're delivered around the world by truck, ship, or airplane. Factory 56 in Sindelfingen is one of the most modern industrial plants in the world and shows us what vehicle production may look like in the future. Here, man and machine work hand in hand and fully networked to build the most popular luxury sedans of all time. A mega project that will hopefully live up to its promises. Eco-friendly and resource-efficient automotive engineering of Industry 4.0.